All right, guys, today we're going to look at some basics of gravity and try to explain why gravity is here. We're going to look at Einstein's theory of gravity and what creates it. So first of all, the first thing we want to do is we want to look at an example of Newton's motion. So what we have here is we have a thin piece of fabric that has been stretched over a wood frame. And so that is going to represent our space. So we start off with one object. So if we take one object and roll it in space, how does it behave? Okay? So how does that one object behave? Well, it's going to follow Newton's laws of motion. And so what we see is one object. Okay, one object is going to travel in a straight line. So one object travels in a straight line, and so that is the natural motion of an object, and we've seen that through Newton's laws, and we've already looked at that information. Okay, so the question now would be is what happens if we have two objects in motion? So we'll start off with, we'll use two tennis balls here. So these two tennis balls have the same diameter and same mass, and so we'll set these in motion. Well, something uniquely different happens now. If we roll these two objects, they no longer roll in a straight line, they roll towards each other. So the next thing we see is two objects now, they roll together, but you might be saying or thinking, well, they're going to roll together because this is created some type of heel, and then they roll because of gravity. Well, what I want you to think about is not that they gravitate towards each other because of the heel, but the fact that when you have one object, it rolls in a straight line. But two objects roll in a curved path. Now in this case, these curved paths intersect with each other and crash together, if you will. The point is this: if it's a curved path, that means there's a change in direction. If there's a change in direction, then there is acceleration. So what we're deciding is that one object follows Newton's laws of motion, and it travels in a straight line. It just rolls out in a straight line. But with two objects, they no longer roll in a straight line. There's some type of change in direction created, and that change in direction is acceleration. And the acceleration we see here is gravity. So what we're saying is gravity is an, if you will, acceleration. And if we accelerate a mass, then it equals or produces a force. So gravity is a force between any two objects. So gravity is a force between any two objects. So if you only had one object, then you wouldn't have gravity. But if you have more than one object, then there is some type of gravitational force that exists. And if we put three objects, then every object would be exerting a gravitational force on the other object. So first of all, step one is one object travels in a straight line. But two objects, you see that straight line no longer exists, that they change direction. So what you're seeing in this is the idea that the mass of the second object creates a change in direction of the other object. If it's changing direction, it's accelerating. If it's accelerating, it's exerting a force. And the force between any two objects is gravity. Now the force between you and the force between me and Earth is my weight. So that is my centripetal acceleration. Now let's look at what actually controls and manipulates this force. So first of all, one object, no gravitational force. Two objects, gravitational force. So let's see what happens if we have a much larger massive object. Here we have this sphere, and it puts a much bigger dent. So let's pause there for a second. Okay? Einstein theorized that large massive objects, when I say large, I mean objects that have large mass, puts a dent in space. And so you see this fabric is dented. And that dent is what creates gravity. The dent is creating a change in direction and acceleration of force and so forth. So let's see what happens now if we place this object in motion. So we try to roll it straight, and you can see it gravitates towards it. All right? Now, so the first thing that controls gravity is you got to have two objects, but what controls it is the object's mass. So if we take these two objects here and we set them in motion, the blue object gravitates towards the steel ball because the steel ball has more mass, therefore it's exerting a larger gravitational force. All right? And if we get this motion just right, try one more time. If we get it just right, we can actually get that blue ball to orbit. Now this is what's happening. The sun is placing a large dent in space, we believe it is, and then the Earth is orbiting the sun because it's trapped in its gravitational field. Now the next thing to take into consideration is look how this curve is. The further you get away from the curve, the less the curve is changing its direction. Closer to the mass has a more change in direction. So let's take the steel ball, okay, we'll place it over here, and let's place this tennis ball over here. Now, which has the larger gravitational force? So if we release the blue ball, it's going to gravitate towards, well, got stuck there surprisingly. Let's try it right here. Let's give it a little motion. That's what we need to do. There you go. It's going to gravitate towards the one with the larger mass. Now, is there a way to make it gravitate towards the tennis ball? Well, sure is. Notice what it does here if we place it right here. Gravitates towards the tennis ball. Why does it go to the tennis ball first? Because it's closer to the tennis ball. So, the two things that affect gravity. Number one, gravity is a force between any two objects. Second on that list would be what controls gravity. One, the mass of an object. Which has more gravity, the blue or the steel ball? Because the steel ball has more mass, it's exerting a larger gravitational force. According to Einstein's theory, it's putting a larger dent in space. Okay, so now, if we have the tennis ball and the metal ball, which will the blue ball gravitate towards? Well, if I put it next to the tennis ball, it's got so much gravity over here we can't make it stop. So how do I keep it from rolling towards it? If I place it further away, the further away I get, the less gravity. So if we place this blue ball here, you can see for just a brief moment it goes towards, because in this case we have much larger mass even though it's closer to it. Which explains this. Is there a gravitational force between me and this table? The answer is yes. So if I jump, do I gravitate towards the table? Well, no, I gravitate towards Earth. Because even if you're really close to this table and you jump off this table, you're not going to gravitate towards the table. You're going to gravitate towards Earth because Earth is much more massive. So what we see is the force of gravity is proportional to the mass of two objects. So you got to have two objects. Each object has its own mass, therefore would exert its own gravitational force on the other object. That would be equal but opposite forces. So if the Earth exerts gravity on me of 200 newtons, then I exert 200 newtons on Earth. And it is dependent on the radius squared. Now that's important, the radius squared. So what this tells us is that if you increase the mass, you create an increase in the gravitational force. As the mass goes up, the gravitational force goes up. But the radius is in the denominator. So if you increase the radius, you'll actually create a decrease in the gravitational force. So this is an inverse relationship. So mass to force is a direct. Radius to force is a inverse or indirect. Now, not only is it indirect, it's an inverse square relationship. So, what we see now is that if we double the radius, okay, so if we have twice the radius, times will decrease the force, but not by half, by the radius squared. So 2 squared would be 4 times less force of gravity. So I don't want to write this as 4 times 4g because that's going to be confusing. It's decreasing by 4 times. So the best way to write that would be you get 1/4 the force of gravity. So this is a key point for us to remember. This will be on our test. If you double the mass of an object, it's a direct relationship to the force of gravity. Doubling the mass simply doubles the force. But it's an inverse square relationship for radius to force of gravity. If you double the radius, if you're twice the distance away, you would actually receive 1/4 the force of gravity. Okay? So we'll put some more information up about this for you to study and review. So again, in short review is, one object travels in a straight line. 2 objects exerts a gravitational force on each other, and that gravitational force is dependent on the mass of the objects and the distance between the objects. More mass, more gravitational force. That's a direct relationship. It would be linear. And then more radius or more distance between them would be a lower gravitational force. It's an inverse relationship or an inverse square, meaning that doubling the force would actually be 1/4 the gravitational force. Okay? Now, that brings us to, we said earlier that the force of gravity is proportional to mass 1, mass 2 over the radius squared. Well, there has to be a way to make this proportion become an equality. What makes them equal to each other? So we won't go into full review, but a scientist, Cavendish, in the late 1700s, early 1800s, discovered this constant, capital G, the universal gravitational constant, and that is the number that makes the ratio of the masses equal to the force of gravity, the universal gravitational constant. And that's important for us. Okay? So that's the universal gravitational constant. All right? And that number, when multiplied by the mass of the first object, the mass of the second object, and the radius between them, will give you the force of gravity. Now don't forget, the force of gravity is, for us on Earth, if this is the mass of the Earth and the mass of you, then the force of gravity is our object's weight. All right, so if I asked you calculate the force of gravity between you and Earth, you would just calculate the weight, mass times gravity. Or you could use the mass of the Earth, the radius of the Earth, your mass, and the universal gravitational constant to determine that. So the last thing is the universal gravitational constant, big G, not little g. Little g is the acceleration due to gravity. Big G's universal gravitational constant, it is 6.67 times 10 to the negative 11 constant. This is the number that makes this relationship an equality. So you should be able to use this equation to solve for the force of gravity between any 2 objects.